I think I will start now. Okay, so good afternoon, everyone. I am Suan Nayan, an EPS student, and currently I am also a student council for this year. So, and today is really, really honored day for me to be an MC, and this is really my pleasure to have all of you here with me, with us, and more importantly, we have Miss Pichsovannthyda An, who is from um, MIS department as our speaker, and she will be present in a topic about Be My Eye. So, anyway, if you guys have any question, please don't be hesitate to drop them in the chat box or right into the Q&A session. And if you guys can unmute yourself, it would be better. So, let's welcome Miss Pichsovannthyda An. The floor is yours.
Hello everyone. I'm Tida from the MIS department. Today I'll present my final year project called Be My Eye. So Be My Eye is a object detection intended for a blind or near blind person to help them perceive their surrounding environment or objects. So an object detection is a program to locate the presence of object with a bounding box and that shows the types and classes and location of the object. So for an object detection, there is an input, which is the image we wanted to for the program to detect, and the output, which is include one or more bounding box, uh, which shown on the image with a point, width, height of the object, and a class label for the bounding box. So for this project of mine, the requirement for in the technological side is, firstly, I'll be using a Python programming language, which will then, my code will be run on Google Colab. It is a environment where you could run it online, which we use in place of the local Jupyter notebook in our local computer. And then we have a GitHub, and then my project will be deployed on a local web through Flash, and the image for my training would be gathered from the Google Open Data Source, Google Open Image Dataset. For the main algorithm for its project is the YOLO version 5. It's also, the full name is You Only Look Once. It means that the image is only passed through the algorithm, which is the FCNN, or the fully convolutional neural network, once. And the algorithm will divide image into grids, and then it will be responsible for the object detection. And it will then give back the boundary box, which has 5 attributes, the X and Y, which is the coordinate, and the width and height, as well as the name of the class and the confidence score. The confidence score is how confident they are in their prediction. So the method I'm using for this project is to use a pre-existing model to build a custom model. So the project I will perform will have the program perform a object detection on class that are not a part of a pre-trained model. In this case, the model that comes with the YOLO version 5 is the COCO dataset. So COCO dataset is just a dataset that consists of 80 different class of objects that we see in our daily life, like cars, motorcycle, books, chairs, table, or something like that. They have 80 different class for it in the COCO dataset that comes with the YOLO version 5 model. So for this project of mine, I will be use the YOLO version 5, but build it on a transfer learning on 20 different object class that is from the Google Open Image Dataset I mentioned earlier. And that 20 different object is not a part of the COCO dataset. And the main algorithm, as I mentioned, is a PyTorch-based YOLO version 5, and the deployment is through Flash. So for the testing for this image is first image are divided into training and validation. We did a 3 batch of testing to ensure that there's no error in the process, such as gathering of image, and to ensure that there is sufficient data for the training. Because if there is an insufficient data, there might be a bias in the prediction, such as the algorithm will not be able to capture the object from the image, or it will give an prediction with the bounding box, but it's of a different class, so it's a wrong prediction, in which we don't want it to do. So this is the class I have chosen for my project, include these 20 class. The reason I chose this 20 class is because it's something it's more like the first category is it's not in the COCO dataset. The second category is that you see it a lot in your everyday life and there is sufficient data. So there are around more than 16,000 training data and more than 3,000 validation data. And these two data is different from one another, so that the algorithm will be predicting a different image and not something they have trained on. And for our testing, as I mentioned, we did a three batch. The first testing is actually a different object from what I shown earlier, and then we did it to test for the availability of data. So there are some object class that are not available on Google Open Image Dataset. However, it should be noted that it might be available on other platform of database, such as ImageNet. But since I'll be using the Google Open source, I'm testing it for the availability. And and the second testing is a new set of object class with 500 image per class and 20 epochs. So epoch is just the number of passes the training or the algorithm has passed through the entire training set. In this case, passed through all the pictures we have trained, which is the 16,000 image. And then the observation from this second batch of testing is that 500 image is still insufficient for my project, and there are still some errors in prediction. And therefore, we did another testing, which is our final batch for this first version of the algorithm, the model. We had a new set, the 20 set I shown, this one. We have decided on this one on the final batch. And then we have increased the limit to 1,000 image per class. It means if there is more than 1,000 image within the database of Google, we will take 1,000. However, if there is less than 1,000, we would be taking all of it. And then in that case, if this set of object that we have chose means the object has high enough of number. For example, even though it's less than 1,000, it would be close to somewhere between 800 to 900 photos, and not as little as like 100. And then we also increased the epochs to 50 epochs. And the observation for this final testing is that there is less error from the prediction. However, we have faced with problem in computing limitation. By computing limitation here, because I'm running it on the Google Colab, the free version of a Google Colab, which you can just run on with your Google account, the Gmail or other kinds of emails, like the school email, they have a 12-hour limit of a runtime. And the time taken to run my model is actually higher. It goes up to more than 24 hours already for this model. So we have faced a lot of limitation. And then it's also a limitation to the GPU, because it's not my personal computer is not doesn't have enough GPU to run it, which is why I've chosen to run it on Google Colab. And then with Google Colab, you have a runtime limitation as well. And so this is the result of the prediction. You might not be able to see it. Let me zoom it in. So these are the result from the prediction. The diagonal line is the accuracy of how it predicts its own classes. So we see that there is some that is quite high, and there is some other boxes outside this diagonal line, which is the errors of the prediction. This is also due to the computing limitation I mentioned earlier, because we didn't have didn't have the computing power to use more image. So, and now we'll talk about deployment. So for this project, for this demo, I wanted to show three kinds of deployment. First is the local environment, which we deployed from my personal computer, and one is hosted on the temporarily on the Prudential cloud environment. So I forgot to mention earlier that this project is made in collaboration with the Prudential AI Center. So yeah, this is also one way of deployment is also on the Prudential cloud environment. And the other is through an API which you call on through the Postman. So now so I'll explain how the deployment with this one works. So this is the, so deployment with CI and CD. CI, it stands for the continuous integration. It means we deploy the code and then it's automatically push the code and build the code. So, and CD is just continuous deployment. It means it will continuously pull the data from the database. So first is the dev environment is our local computer, and then in which we commit the program, the file to the GitHub main branch. However, this GitHub for this project is a private repository. And then after it commits and it builds, it will be containerized to a Docker. So Docker is like you packaging a file into one file for other people to use. For instance, even though it's the same file and we will be sending the file to other people, they might not be able to use it. There are problems such as the computer does not work, different library, different environment, different dependency based on their computer. So after it's containerized into a Docker, then that means everything that is required to run the project will be mentioned there in the container. So that means other people will be able to run the program completely. So it's like wrapping the package and it's like giving the full access to your computer, like the file from your computer in their computer. So, and by using a Docker, it's usually a best practice in deployment. Like for Prudential, everything is containerized. And the next after it's containerized is it will push into the ACR. It's the Azure Container Registry. It is a Prudential Azure environment in which we can push and pull data from there. And after it's we push it in the Azure App Service, we can pull image from the ACR to run in and then to expose it to the user. And this is like what we want them to see and not the whole back end, to which we can, in this case, we expose it as, we can, like I mentioned earlier, two ways. And one is like a web app and the other one is the Prudential REST API. So this flow is written just for my project, and it's in Azure. We assume that it passed the GitHub unit test. So now let's move on to the demo. So firstly is the local computer flash. We just have to go to our local host at port 5000. And this is a screen you will see. You would have to choose a file from your computer. So in this case, I have file downloaded. and then we just choose a picture, for example, this one, and then we upload the picture. And then it will, the machine will give us the prediction. In this case, this purple box is the bounding box, and there is the width and height, like the size of the object and the location where the bounding box is. Like it's supposed to tell the machine where it is, and this is the class it predicts with the confidence interval. Like the machine is confident that in 68% confident that the object inside the bounding box is a tree. So, and then now we would see the deployment on the web app for the Prudential Azure environment. I have already go into the website. This one is prudentialbemyi.azure website. So it's the same thing, basically the same thing, but you host it on different environment. So this is the same thing. I'll predict a different image. So this is the prediction. We had a helmet class. So as you can see, this is like a picture from a road where everyone is wearing a helmet and this guy is not wearing one. So the machine will be able to predict most of the helmet that is on the picture. And then with the one that is not having a helmet, there is no prediction because they don't find an object. So it means with a lot of object in the image, our model, the best one, did not manage to make an inaccurate prediction. So now we will see it through a REST API. So we just have to paste the REST API. And then this one we will get a post because we are trying to upload an image into the program, the algorithm, the model. And then for the body, since we're uploading a project, it's in a form format. And then we just use like a file, a name for it. And then the format will be file. And we select file similar to we did earlier. And this time I'll predict this image instead. I'm showing you a different image so you see how it predicts a different file. So that's all. You just have to send it and wait for a bit before the machine gives back the image. So yes, this you might not be able to see it clearly. So in this image, one of the class I have is coffee. So as you can see, the image is, there's coffee, it has a prediction on it, and the cups without the coffee, although it has the same look. Like usually when you insert an image of a coffee, it's like in a cup. So technically when you deploy, you had the machine predict it, it will capture the something. If there's not enough image, it might just detect the size or the look of the cup and just have it say coffee. However, in our case, with sufficient image, it only shows the coffee part. Although this one has prediction of the outside, which can be, say it's a little kind of error, but the inside is still a coffee. And the one without any drinks on it is not detected by our model. So, and another case, which I will show you in this one because you don't see a picture clearly in the Postman. So this one has a picture of different kind of drinks in which this is tea, this is coffee. So as you might think that coffee and tea has a similar look. So would the machine be predicting it inaccurately? So we have tried it on this picture and you can see it only predicts the coffee. Tea was not wrongly predicted as coffee. And this one you might think it's coffee, but it's actually a chocolate. So it's not predicting as well. So as you can see, the machine has quite a high accuracy, especially for this few classes I've shown. There's also other class, but let's. I haven't tried. I haven't downloaded image for to show you. I'll just show this much. So yes, this is all for my presentation. You.
Thank you so much for your presentation. I really enjoyed it so much because it was so intelligent idea from you, and I love the idea. So, um, do you guys have any question want to ask our speaker?
Hello. Hi. I have a question for the last picture that you show detecting between the coffee, okay, a cup of coffee and a cup of chocolate. Do you think what is the reasons behind that the model kind of be able to really distinguish and is very accurate? Even myself, I was thinking that's a coffee. I wouldn't think it's a chocolate at all. So I want to ask you, Nida, and yeah, from your point of view, you think what is make the model be able to give that very accurate predictions or detection?
So from what I think is because firstly, we have sufficient data for the coffee class. So the machine will have sufficient image to train to understand what coffee is supposed to look like. And the second thing is that with coffee, that is what I personally think the characteristic of a coffee is that usually compared to chocolate, coffee usually have like these kind of stains outside of the cup, which is like brown, light brownish. It's like the crema. So for one thing the machine might understand is that with these kind of brown stain outside, it is a coffee. And chocolate, because it doesn't have any stain outside of it, it is not a coffee. So that's what I personally think the machine understand from the model that I trained understand from this image.
Yeah, it's very reasonable. How about one more questions about the coffee? Hot coffee and iced coffee. Do you have any picture that this model can detect iced coffee and hot coffee? Can you go deep down to a different type coffees?
So then let me go and download an image for you because don't have that image saved to for this demo.
Yeah, I kind of a coffee lover, so I kept thinking when you show the coffee pictures, I was thinking, yeah, it's good to. Sometimes I don't know even how far we can go, even detecting what beverage is iced cappuccino, espresso. Do we have that level of detection or accuracy? I don't know, but I think it's very interesting. Yeah.
Miss Tina, do you say something because I'm afraid that you forget to open your mic.
Oh, I've been talking a lot, so sorry. So, what was I just now? So to answer Miss' question about the cappuccino and like espresso kind of thing, did you manage to hear my explanation just now, or was I also on mute?
No, I couldn't hear you as well. I just start
Oh,
hearing you
sorry,
from now. Yeah,
sorry,
yeah.
sorry. I've been explaining it. So, uh, for that question, I would just use this image to explain it. So, for example, because we generalize the classes to the coffee, that means all kind of coffee would just be predicted as coffee. If we wanted it to have a narrow kind of class, like example of what you mentioned, espresso, cappuccino, and stuff, so it will we would have to download different image that we categorize as those category, and we might have to do it manually because from what I know, in those image database that is available on internet, they don't usually go very narrow into kinds of coffee. So we would have to go and download the image by ourselves and have it in a file for the machine to train on. And then for uh, in the case of espresso and cappuccino you mentioned, so if we were to train enough image for the machine, something like this and this would be espresso, and something this would be like a latte. So the machine would understand the difference as there is no picture on this one, so there's a latte art on this one, so it might be a latte. And in case of a cappuccino, it would be something like a white top with like cocoa powder on top or like chocolate powder. It's like the machine will find those little things that differentiate one from another type and then categorize it. But there are also cases that it might cause a wrong prediction because sometimes the coffee just look very similar. In a case such as the shop will have a cappuccino, make it look the same as a latte. It's like with a latte art, but it's more like different kind of content of milk. Like usually cappuccino is more foamy. So like the machine won't be able to see it. So sometimes like example, cappuccino might be wrongly predicted as latte. There's always those kind of risks in errors in prediction, those kind of narrow stuff that look similar to one another. And yes, so in the case of iced coffee and hot coffee, because I don't have an image for it, so I'll just explain it. It's similar to this one because in my training, I use both the hot coffee and iced coffee into same category as a coffee. So meaning it will technically, if there's 2 cups, it will just give a same prediction as um, both as coffee. We didn't specify it as ice. We didn't specify it as hot. So like I mentioned earlier, with enough image and data for the machine to train on, the machine would be able to differentiate it. But there are also certain risks that it has the prediction, like this accuracy confidence interval that it has. So yes, does it answer your question, or you want to ask a follow-up question?
Thank you very much. Yes, thank you very much. Yeah.
Yeah.
I have a question. Um, I want to ask that what made you come up with this innovation? Like, why do you interesting into this kind of data?
So to clarify, the question is why did I choose this project, right? So actually, to be honest, my first choice of final year project is actually not this one. So then after I was approached by the Prudential AI team, to ask them to, which asked me to work with them on this project. So and then it became in which after they have explained the program details, like the requirement for what they wanted it to be from what it could be, and how they would use it. And then after that, I was interested in this project, which is why I agreed to their proposal and take up this project. So yeah. So technically, to be more detailed, um, their I their idea was to use this for what I mentioned earlier, like a near blind or blind person. So near blind person is something like people who is not fully blind, but they could only see like something like blurry and not too clear. So what they wanted this to be is an like a program. It could be a standalone application, or it could be integrated to their own application in which I I know they are developing one, so which I could not disclose any further information because it's for confidential. So yeah, they want for this project, they wanted it to use it and then to integrate into their app so that user would be able to use this app example to perceive their surrounding. They would also add another feature with like some other team is doing is like the voice kind of like alert. So this is like a prediction with just an image. However, blind people can't see it. So technically, they would have like a voice on top. Something like, example, in this image, they would just have, oh, there's coffee in front of you, or something like that. So yeah, that's why it's quite interesting. It's quite it target a very quite a niche audience that some people might not be focusing on. So yeah, that's why I was very interested in this project.
Thank you for your splendid project that you come up with a very um, great and intelligent idea. So, do you guys have any more question?
Yeah, I have one question to
Oh no,
me too.
why you here too long?
Uh, uh, okay, so the questions would be quite simple. Like, when you were doing the AI part, excluding CI/CD and so on, what would be like the most challenging part, and what would you do differently to avoid that?
So let's just say the most difficult part of this project for me is the training part, because firstly we would, since it's for, as I mentioned earlier, I have quite a bit of image for this project. I would have to find the class that has sufficient image, and the image is would be able to generate a quite a high accuracy of model. And then it's also the computing problem, because I mentioned I'm using a Google Colab. They have a 12-hour limit on their platform. So I took more than 12 hours to train the model alone. So I have some problem, and there are times where it just ends, like the runtime ends before the time even reach. So I wasn't able to save the model. So then it's like I would have to redo it. So yeah, it was like more like a computing kind of problem that I faced the most, and also paired with the time limit of this uh, presentation, the time limit for the final year project, because it's technically it's required before the actual deadline of the prudential's deadline.
So you did not save the weight periodically, like every 10 epoch or something? No?
It's like, yes, it is safe every epoch, but there are certain times that it ends, like it nearly ends the epochs. It's like there's only a
Oh,
few percentage left, but
okay.
then it ends. So that would mean I would have to rerun it, and then sometimes it's just like I would have within the 12-hour limit. I managed to use example like 8 hours, and I have 4 hours left. So and then I continue the running afterward, and then the first epoch that I resume, it would take a
Uh-huh.
bit of time before it goes into the normal speed. And then sometime the time limit just end before the first one even finish, the one I just resumed. So meaning I would have to resume that long first
Mhm.
epoch again.
Yeah. Did you try any fine tuning? Um, Hi.
Um, we did not do much fine tuning because
Mhm.
this one is just the first version. We might be able to do it later, yeah, because this is just a testing version of the program.
Okay. Okay. Cool. Thank you.
I have another question. I am interested into you said that blind it's useful for blind people. So
Thank you.
I I wonder that how can blind people use it? Like it should have something to tell them through the platform. So I wonder how can those blind people know that, oh, this is coffee or something in front of you or whatever. And do you think that it is so risky that they need to hold their phone along the way while they cannot see anything and just to scan what's in front of them and what's next to them?
So yes, I did. I think I did mention earlier that um, Prudential has a plan to include a voiceover for all prediction. Like they would have a voice telling the user what object they have detected. So, however, this is not the part of my project. So, yeah, they do have a plan for it to have a voice. So technically, the blind person would just have to hear it. But if you're trying to say the blind and if there's cases that they are deaf too, then technically they can't use this app. So yeah, there's no choice for it. And so yeah, it definitely is a risk for them to be holding their phone and walks everywhere. But it's more like I think they are more like somewhere they are going, um, not too risky. Like not they are walking around along the road, like literally just out there and then walking it because there will be chances of people stealing your phone. Even if you are not blind, sometimes you have it out anyway when you're walking, and there's always still chances for it. So, but yeah, the program is aimed to solve them. Like for example, like certain object that is in their way that they will might not be able to see it, or like feel if they have like a walking stick. Sometimes it just like when you move it around, it just doesn't touch anything. So the machine might be able to tell you that there might be an object there so that you could avoid it. So yeah. Does this answer your question though?
Yes, yes. Thank you for your
Okay.
answering. So I think this is the end of our session now. So maybe before its end, can I have a group photo? Can you guys open
So
your
I have to
face?
open my camera.
Yes,
Oh no.
please.
Oh, so yeah.
Okay, so I will
That's just me
count
and
it.
you though.
Okay, so
I will join you guys as
And
well.
yeah, I'm
Oh,
joining you
yes,
too.
yes,
thank,
cool,
Yes.
cool.
Actually, I
thanks.
want to get to know you more too. I'm very interested in your project.
Yeah, definitely. We can keep in touch on that. Wait, you talk to her, right? Sorry.
Both of you,
Yeah.
both of you,
Okay.
both of you. Yes.
So I will count it. Here, one, two, three.
Oh no.
Okay, thank you so much
Yeah.
for your splendid you know, your speech, everything, your idea, and I really love that. So wish you good luck with your project. Thank you so much.
Yes, thanks. Thank you. Thank you.
Thank you.
Yeah, just one thing, for Tida, where can I find your report to read or your final year report to read?
So the